This next set of videos is going to teach you how to solve non-right angle triangles. So when you have a right angle triangle, you can use Pythagorean theorem or you can use the three trig ratios. When you have a non-right angle triangle, you can use what we call the sine law, or what we're going to learn next is what's called the cosine law. So the sine law is used only when you have a known angle across from a known side. So to use the sine law, you have to have one known ratio. You either have to know angle A and the side across from it, or angle B and the side across from it, or angle C and the side across from it. You only have to have one known ratio. So the way that we set up the sine law is that if you want to find a side, I always put my unknown on my top. So if I want to find a side, I'm going to put the unknown side on the top, and across from it, I'll have the ratio of the sine of the angle. Now, if I was solving for angle A, side A, I'd have to know side B across from angle B, or I'd have to know side C across from angle C. So you're only going to use two of these. So you'll say maybe A is to angle A as B is to angle B, or A is to angle A as C is to angle C. So you're only using one proportion, so one part of this equation. So let's look to see what that means. So here is a non-right angle triangle. You can tell because there's no square in a corner. And this says solve for side B or side C and B to the nearest 10th. So looking at this question, I have a known angle across from a known side. What that means is that I can solve for either an angle or a side, depending upon what else is known. So here I also know another angle, so I can solve for the side across from it. So if this is angle C, I'm going to call this little c. So to set up my proportion, I never use for these ones I don't write literal equations, I just think of what it's doing. So it's setting up proportionality. It's saying side C is to angle C. Now angle C won't have any value unless you put the sign with it. So it's saying side C is to the ratio of opposite to hypotenuse for the angle 72 as side B, A, which is 6, is to the angle across from it, so the sine of the angle 56. So using this proportional statement, I can now solve for side C. And by setting this up with my unknown on the top, it's really easy to solve. All I have to do is multiply both sides by the sine of 72. So I'm going to plug into my calculator 6 times the sine of 72 divided by the sine of 56. Now, depending on how your calculator works, you might want to type 6 times the sine of 72 equals, and then hit divided by the sine of 56. It should know where to put the brackets, but if it doesn't, just be careful. So to the nearest 10th, you should find that side C is 6.9. So now I want you to use the same triangle, but this time I want you to solve for side B. So B is to angle B, but we don't know angle B. But we do know a rule. Angles in a triangle add up to 180 degrees. So A plus B plus C is going to equal 180 degrees. So if I'm trying to solve for angle B, I'm going to take 180 degrees and subtract the other two angles. So minus 72 and minus 56. So angle B is 52 degrees. So side B is crossed from the sine of 52 degrees, just like. Now, you have two known proportions. You have side C that you know across from angle C, and you have side A across from angle A. You can use either proportion, but because we just solved for C, I'd have to use an unrounded version, which means I'm keeping a lot of numbers. And what if I made a mistake? So I always use known values if possible. So I'm going to say side B is to angle B, as side A, which is 6, is to angle A, which is 56. So then to plug this into my calculator, again, to solve for B, I just times both sides by the sine of 52. And I get B equals 6 times the sine of 52 equals divided by the sine of 56. And I get to the nearest 10th 5.7. 7. So this is how to use the sine law to solve for a missing side. The next thing we're going to do is use the sine law to solve for a missing angle. So it's the same. We have to have an angle across from a side that's known. But the difference is that if I want to solve for an angle, instead of putting my side on the top, I put my angle on the top. So I would say that the sine of angle A is to side A, as the sine of angle B is to side B, as the sine of angle C is to side C. So all I've done is take the equation and flip them. You don't have to do this. This is technically the root form. This is the root form of the sine law equation. This is the one that you would see written in your textbook and so on and so forth. I just like solving this with my unknown on the top so I don't have to do a bunch of weird rearranging, because we're just setting up proportions. So as long as my angle is to side as another angle is to side, I'm good. Just like I could do a side is to an angle as another side is to an angle. It doesn't matter where they go as long as they're proportional. So this one, they're not giving me all the information. They're saying solve for angle R in triangle PQR if. So it doesn't matter where you put PQ and R. I drew this triangle and put the letters on it because when I teach it in class, I kind of want everybody to put them in the same place just so that I don't have to explain it in different ways. But if you put Q here and P here and R here, it would still work. So it says solve for angle R if angle Q is 115 degrees, so there's a known angle, side R, which is across from angle R, is 4.5 centimeters, and side Q, which is across from angle Q, is 10.8 centimeters. This time, I'm asked to solve for an angle. It wants me to solve for angle R. And I could have guessed that that's what it was wanting me to solve for, because here's my known ratio. I have a known angle across from a known side, and the only other thing they gave me was a side. So using proportions, I could solve for this angle. So I would set it up as the sine of angle R is across from 4.5, just like the sine of angle 115 is across from 10.8. So again, to solve this, my unknown's on the top, so I'm just going to multiply both sides by 4.5. So that gives me sine R. So if I plug that into my calculator, I've got 4.5, or sine of 115, whatever you want. I like to do 4.5 times the sine of 115 equals divided by 10.8. And that gives me this answer, 0.3776 ... This is my ratio. This is the ratio of opposite to hypotenuse. So now to solve for the angle, I have to use my trig tables in my calculator. So to solve for angle R, I'm going to take the inverse sine. So think of what's the opposite operation of sine, it's inverse sine, or you can think of what your trig tables are doing. If I want to give it a ratio and tell it to give me an angle, I use the inverse sine. But I'm going to take the inverse sine of this. Now, if you remember from the other video, this is stored in my calculator. So if I now type inverse sine, now I want the answer. So if I do inverse sine of the answer, so on my calculator I have to hit alpha, so that takes me to everything written in blue. And for me, I have answer written above my equal sign, so I hit inverse sine of the answer. Some people's calculators have an actual answer button on them. You can just hit that. Some people have to use store and recall. It's sort of dependent on your calculator. But I'm going to hit equals. And if your calculator won't do any of those, just write down at least 4 decimal places and do it. But we should get that angle R to the nearest degree is equal to 22 degrees. And that's how to solve for an angle using the sine law. So now here's the ultimate question. This question says solve the triangle. So what don't we know? Well, we don't know angle P, we don't know angle R, and we don't know side P. So we have 3 things that we need to solve for. And we need to first off notice that this is not a right angle triangle. So when you're doing your test, for example, you're just going to say solve the triangle, and you have to decide, well, what type of triangle is this? What am I allowed to use? Because this is not a right angle triangle, the only thing I know how to use right now is the sine law, because I have a known side across from my known angle. There is my given ratio. So what else did they give me? Well, they gave me a side. So I'm going to use this known side to solve for this angle. So I'm going to suggest that you pause the video because I've done all the setting up so far. Now I'm going to pause the video and I want you to set up the sine law to solve for angle R. So I'm assuming you all paused the video, and when you solved it, you set up that the sine of angle R is across from side length 41, just like the sine of 39 is across from side length 28. So to solve for the sine of R, I multiply both sides by 41, so I get 41 times the sine of 39 divided by 28. And then to find R, I'm going to take the inverse sine of whatever I got there as an answer. Alternatively, you could do inverse sine bracket 41 times sine 39 divided by 28, sort of whatever works for you. But I'm going to type in 41 times the sine of 39 divided by 28 equals, then I'm going to go inverse sine of the answer. And I get to the nearest degree, let's say, because it said before nearest degree. So let's go 67 degrees. So that now tells me that angle R is 67 degrees. So now it's asking me to solve for the whole triangle. So if I'm going to use this answer again, I have to use it in its unrounded form. So this answer was actually 67.1470829. I can either write that down, I can hit store as A, so that if I have to use it again, I can just pull it up. Totally up to you, okay? But the next thing I have to solve for is this missing angle and this missing side. So the easiest way to solve for an angle is that if I know these two angles, to solve for this one, I can just subtract from 180 degrees. Alternatively, if I don't want to use this rounded, like this unrounded answer, I could set up my sine law again. So I could either set it up as sine of angle P, oops, no, I can't, never mind, because I don't know side P. Look at that. So I can't do it that way, so I have no choice but to subtract from 180. So if I want to find angle P, I'm going to do 180 degrees minus that 39, which is an exact value, and then minus the 67.1470829, the unrounded version. So I'm going to do 180 minus 39 minus, now my calculator still has it, so I'm going to do minus the answer, and I get, and again, if I'm going to use this again, I have to keep it unrounded, so 73.85291701, which if I was giving it as a final answer, angle R is 67 degrees, angle P is 74 degrees. So the boxed answers are my final answers, but I have to keep my unrounded versions as well, because the last thing I have to find is the side P, which is why I had to use this to solve for angle P. So again, this is a non-right angle triangle, so my only option is to use the sine law. To use the sine law, I have to have a known angle across my known side. I already know I have Q across from Q. And so to solve for side P, I have to know angle P, which I'm good to go. So I'm going to solve for side P because it's across from the sine of that angle. So I'm going to use the 8.85291701, which is across from, now always use the one that you were given. So 28, so just like 28 is across from the sine of 39. So again, to solve this, I'm trying to solve for P, so I'm going to multiply both sides by this. So P is going to equal 28 times the sine of 73.85291701 divided by the sine of 39. So again, maybe you still have that sine 30, or maybe you still have that 73 degrees answer in your calculator. Maybe you stored it as A or stored it as B, but we're going to use it again. So I'm going to hit 28 times. Now I'm going to type sine of, I still have that answer on my calculator, so I'm going to hit sine of the answer equals, and then I'm going to divide that by the sine of 39. And so this one, again, I'm going to assume that I'm rounding to the nearest whole number because it's the only thing it said above, and I'm going to get 42.7, so I'm going to say 43. So that's my final answer. So my side length, my unknown side length P is 43 units, my angle P is 74 degrees, and my angle R is 67 degrees. I've solved everything I needed to in this triangle. All right, good luck with the sine law.